Hi everybody, and thank you again for watching another episode of Gaffer and Gear. In today's episode, we're going to take a look at these Godox professional pixel tubes. So this 2-foot tube has 16 pixels and the 4-foot tube has 36 pixels. They are full color gamut with a CCT range from 2000 Kelvin up to 10,000 Kelvin with plus minus green magenta correction, and they have all of the professional DMX profiles you could possibly want. So as a professional gaffer, why might you be interested in these? Well, they have an IP65 rating, so they're weather resistant, and they've got my personal favorite thing, which is built-in CRMX control. Okay, let's start off with cost and what you get for your money. Now, depending on your point of view, these might be expensive or good value for money. So if you're just looking for an all-round tube that can do color, then these are definitely on the expensive side of the spectrum. If you're looking for a tube that has a weather protection rating that you can use outside in the rain and has built-in CRMX, well, this is about 2/3 the cost of your other options that are out there. All right, so let's start off the pricing here. So I've got the 2-foot kit single, and I've got the 4-foot single kit. So we'll have a look at the 4-foot single kit first. This sells for $570 US and around the 900 Australian dollar mark. So you get a very good bag for that. You get the tube, of course. Now the tubes, look, they're as well built as anyone else's tubes. Things I like about the tubes, you've got these flat edges here so it doesn't roll around on your surfaces. You've got mounts at either side as well. And of course, everything's plugged up for the weather protection rating. So you get the tube, you get an instruction manual, which I've managed to misplace. Now, here's the instruction manual. I'd recommend having a read of this first. We'll talk about that later. You get a power supply and you get your original power cable. You get 2 of these cables for mounting, so these interlock in on themselves. You get 2 of the eyelets, so you can suspend the tube. And you get 2 of these clamps. Now the clamps look a little bit like a Titan clamp, but they do have a difference. They unlock here, as opposed to the Titan clamp, which just sort of locks onto the tube. And you've got this safety catch here to make sure that the clamp doesn't unlock on you. Now let's have a look at the pricing on the 2-foot single kit. So this sells for about $400 US, around 650 Australian dollars. Now it pretty much has the same contents as the 4-foot kit. It has the same accessories with one difference. Instead of having 2 of these clamps, it only comes with the 1 clamp. Now you can get these in different kits. You can get kits of 4, kits of 8, and in terms of price, they seem to come in at about 2/3 the price of a Titan kit, just to give you some idea. All right, now let's have a look at some of the optional extras that you can get. So this is the floor stand. This is the TP-FS60, and this sells for about $30 US and around 40 to 45 Australian dollars. This thing really is solidly built. It is weapons grade build quality. It's very strong. It's not going to bend on you anytime soon. What I like about it is they've got it done up tight, so you know the legs aren't going to fold out if somebody accidentally walks past and kicks it. Very, very solid. In terms of operating it, look, it really is straightforward. Just screw the tube into it. Now, the first time you do this, you might struggle a little bit because there is quite a bit of powder coating overlapping on both the stand and on the end of the tube. But look at that, very, very solid. Now, the next accessory that the accountants at Godox have let the salespeople send to me for review is this 4-mount adapter called the TP-B4. And this sells for around $190 US, about 250 to 260 Australian dollars. So this consists of 2 parts. You've got your plate that the tubes mount to, and the locking system is the same clamps that are sold with the tubes. So you've got your lock here, and you've got your safety pin to make sure nothing falls out. Now the second part is the ball mount that attaches to the back, and this is absolutely crazy. I cannot figure out how they make something like this for the price. This is all solid steel. There is no plastic anywhere on this. The engineering is superb. Look at that, absolutely crazy. Now this can mount horizontally or vertically, so it just slides on. So you've got horizontal, or you can go vertical. Now just a note here on the back is In order to lock it, you have to line up the screw here with the capture nut on this side. Now, when these are new, there's quite a bit of paint on them, so you might have to give it a technical tap to get it into place the first couple of times so you can line up that thread. And in terms of taking it off, you might also have to give it a technical tap to get it apart, because there is quite a bit of paint there initially when you're starting out using the unit. Now, people are going to ask, can this fit Titan tubes? So this is the Godox tube, and this is a Titan tube. Yes, it can. Now, the last accessory they've sent me is a power station. This is called the TP P600 kit, and it sells for around 460 US dollars, around 600 to 670 Australian dollars. Right, so let's go through what you get in the kit. So the power station is solidly built. You've got a Nutrix connector here, on-off switch, and you can power up to 8 lights off it. You also get your Nutrix connector with your regional power plug, and you get 8 of the power leads to connect between the power box and the lights. Now, these are decent cables. They're not that PVC rubbish. They're actually made of rubber, and they're about 5 meters in length. Now, just to give you some stats on the power board here, the power box can supply up to 600 watts total, and each outlet can power up to 105 watts. It does have a handle that you can use as a mounting point. It has some sort of clamp mount here, so I'm guessing there's a clamp available for it, and you've also got rigging points here at the top. All right, so let's go through my list of pros and cons, starting off with the cons first to get those out of the way. And the first con is a little bit technical. It's to do with how this tracks to the Planckian curve. Now, up at the daylight end, the light is tracking somewhere between the Planckian and the daylight curve. Now, this is actually a good thing, because if you're using a camera that is on the daylight curve, then this light is going to be a little bit below that, imperceivably magenta, and vice versa. If you're using a camera system that tracks to the Planckian curve, this light is going to be slightly above that, and it's going to be imperceivably green. So they split the difference there. Everybody's happy, no one's going to notice any difference. Now, despite the fact that the daylight curve doesn't go below 5000 Kelvin, this light tracks to that same split difference across its entire CCT range. So that means, compared to all our other lights, which track to the Planckian curve in the warmer Kelvins, this light is going to be slightly green if you don't dial in any magenta correction to roughly the equivalent of a 1/8 correction gel. Let's get into the next possible negative for me now, and that is the pixel control options you have over the phone app. All right, so let's have a look at the list of effects we've got. There's quite a few here, but not that many of them are pixel effects. So the first one we've got is this RGB fade, which I've got running here. So you can select how many colors you've got, for example. Let's put a third color in. Now, one of the things I find a little bit irritating with this app is if I reduce the amount of colors from 3 back to 2 and then decide I want that third color back, it doesn't seem to remember what that third color was. So that's a little bit irritating there. You can do things like adjust the length of the pixels, and you can do things like adjust your colors, of course, but you can change the direction at which the effect's happening, and you can set your background color. Okay, so pretty straightforward. Let's go back to the list now. The next thing you've got is this RGB flow. Okay, so that's the next pixel one. Look, the same sort of adjustment parameters. So we can adjust how many colors we've got, for example. You know, we can adjust the length, we can adjust the intensity, we can adjust the speed. Now, if things go out of sync with each other when you're doing your adjustments, what I have found is if you click on the button up in the top corner and turn it off and then turn it back on, that can resync. Now, in terms of sync, you can see I'm running a group here, so everything's getting the same command. The 4 foot are staying in sync with each other, the 2 foot stay in sync with each other, but they haven't got it programmed so that the 2 foot and 4 foot are doing the same thing at the same time. Let's go to the next pixel control thing that we've got. We've got RGB chase. Okay, so this has the same adjustment parameters. Look, I've got to say, maybe it's my limited intellectual ability, but all 3 of those just seem to be the same effect running slightly different. I don't know, maybe I'm just not understanding this. Now, To find the next effect, we have to go, that uses pixels, we have to go all the way down to fire. Okay, and then the next thing that uses pixels is the cop car. So pretty much in terms of running pixel effects over the phone app, it's very, very limited. If you want to do anything sort of adventurous with pixels, then you have to use DMX. Now, another thing with the phone app, it's standalone effects. You can't have, for example, an effect going from one tube and then crossing over to another tube. It's only individual tube effects. Continuing through my list of negatives, the 2 foot only comes with the 1 clamp. I understand where they're coming from. This isn't all that heavy, but you can't always rig to the center of gravity. All right, continuing through possible negatives in terms of clamping, the inputs and the controls are not recessed like the screen is. So if you need to clamp into this section here, what can happen is you can end up blocking access to your ports. And if you're clamping down here, you can be pressing on buttons. The last negative for me is the operation buttons for the menu system. It doesn't use the plus and minus buttons to scroll up and down the menu system. If you want to scroll through your options, you have to press the function button. Now here's my first issue with that. This thing has 22 DMX profiles, for example. If you go past the profile that you want, you have to keep pressing the function button and scroll through the entire menu again to get back to what you wanted. But here's the big thing you need to be cautious with. The plus button is the enter button when you're going through your menu. So when you first turn these things on, you get asked if you want Chinese or English. So if you press the plus or minus button to scroll through, you accidentally end up setting the tube to Chinese. Okay, let's go through my list of pros. I love the multiple flat edges on the ends. So you can put this on a table and you can angle it to loads of positions. It's not going to roll around. You don't need to put clamps on to use this on a table. It's also not back heavy like, say, your Astera tubes, where you put them on a table, they always roll onto their back and face upwards. The next thing I like about this, or the next pro, is the battery life. Running this thing at 5,600 Kelvin at 100% brightness, you get a fraction over 2 hours of battery life. And when the battery starts running flat, you get a flashing red indicator on the back, so you know it's going to happen. The next pro for me is the color render above 2,400 Kelvin is absolutely superb. The next big pro is the IP65 rating. You can use this outside in the rain. And the last big pro for me is the Sierra MX is actually superb. All right, so let's start talking about the DMX. Now you can run this via hardwired DMX, 5-pin XLR, via the USB-C port here. You can get an adapter cable that has DMX in and DMX out. Now I don't have that adapter cable, so I can't show you it. So today we're going to go through the Sierra MX. Now one of the things I like about this light is as soon as it receives a Sierra MX transmission, it switches over to DMX mode. But not only that, the display switches over to the DMX menu, which is what we need. So the first thing on the menu is your DMX start address. So 9 times out of 10, that's the first thing we need. That is straight away on the display, first thing on the menu. The next thing we're probably going to want is the DMX profile, which is the second thing on the menu. Now, in terms of DMX profiles, this has 22 profiles. So it's got the 11 profiles that are listed here in both 8-bit and in 16-bit. The next thing on the DMX menu is your pixel count. So at the moment it's set to 1 pixel, but we can set it to 2, 4, 8, 16, and if you have the 4-foot tube, you can set it to 32 pixels. So I'm going to put that back to 1 pixel. Next thing down on the menu system is your loss of behavior. So I've got this set to hold. You can set it to hold for 2 minutes, or you can set it to go to blackout. And the last thing in the menu system is the RDM, remote device management. Now here's the thing I really like about this light, and that is the little green indicator here. So that is your Sierra MX status light. It drives me nuts that this isn't included on all lights. So what does that mean? Well, the fact that it's turned on and it's constantly glowing indicates that the Sierra MX is turned on, it's linked to a transmitter, and it is currently receiving a transmission. So if I walk over to the light because it's not responding to commands, and I see that this light is fully illuminated like it is now, that leaves one possibility: human error. So most likely I've got the wrong DMX address programmed into it. Now, for example, if that light is flashing, that means it is locked to a Sierra MX transmitter. It's got its Sierra MX turned on, but it is not receiving a signal. So for example, in this circumstance, it could be out of range of my transmitter. Possibly I might have rented this out to somebody and they've locked it to their transmitter. Okay, so it gives me an indication of what the problem could be if I'm not getting a command going through. And if that doesn't light up at all, that means one of two things. The CRMX is turned off in the menu system, or if the CRMX is turned on, it's not linked to a transmitter. So that little green light there can save a lot of time when it comes to trying to figure out why you're not getting a CRMX command going through. Okay, let's start the DMX testing. I have the Godox receiving its commands via its internal CRMX receiver. It is running off an 8-bit CCT HSI crossover profile, and its dimmer is set to linear. To give you something to compare it to, I have a Titan tube, which is also receiving its commands via its internal CRMX receiver. It is set to its default dimmer curves, and it is also set to an 8-bit CCT HSI crossover profile. Throughout these tests, both lights will be receiving their commands at the same time. Let's start off with instant on-off commands. Now let's have a look at some half-second cues. Now let's take a look at some 1-second cues. Now for some 2.5-second cues. And now for some 5-second cues. Now let's have a look at some CCT changeovers between 5600 Kelvin and 3200 Kelvin, starting with instant changeovers. Now some half-second changeovers. Now for some 1-second changeovers. Now for some 2.5-second changeovers. And now for some 5-second changeovers. Now let's have a look at a crossover between white light and a color hue. Now the Titan tube doesn't do the best crossovers here, so I'm going to do a comparison a bit later on with a sky panel as well. Let's start off with instant changeover commands. Now a half-second command. Now a 1 second command. Now for a 2.5 second changeover. And now for a 5 second changeover. I'm going to redo that section of the test with a sky panel. Now, despite the sky panel being the equivalent of a great granddad when it comes to light engine technology, these things are still really hard to beat when it comes to doing DMXQ. So that's why I'm going to test it with it. Now, if I don't mention this, somebody's bound to jump to the wrong conclusion. This is not a brightness test. In fact, the sky panel has 4 f-stops of ND attached to the front. Both lights are receiving their commands at the same time. Let's start off with instant changeovers. Now let's have a look at a 1/2 second changeover. Now let's take a look at a 1 second changeover. Now a 2.5 second changeover. And finally a 5 second changeover. Let's start going through all the data I've collected, starting off with the brightness and the dimming characteristics. These brightness readings were taken at a distance of 1 meter, and the f-stop readings are measured at 400 ISO. Now, because these readings might not mean a lot to people, let's do a comparison to a Titan tube. And the Godox tube is brighter. At 3200 Kelvin, it's 8% brighter. At 5600 Kelvin, it's 16% brighter. But the real difference is in the full saturated colors. Red is nearly 5 times brighter, green is nearly 3 times brighter, and in comparison, blue doesn't really seem to be pulling its weight. It's only 68% brighter than the Titan tube. Now let's take a look at the dimming characteristics. According to my frequency meter, this light is running scattered pulse width modulation, and as far as I can tell, it is high-speed flicker-free. Let's take a closer look at the dimming characteristics for 3200 Kelvin. I've taken readings at 100%, 50%, 25%, 10% and 5%. The CCT remains very consistent, the TM30 color render score remains the same, and the white point or delta UV has a little bit of shift towards green at 25 and 10% to roughly the equivalent of 1/2 of a 1/8 gel, and at 5% brightness it skews towards magenta. That total magenta skew is about the equivalent of a 1/8 correction gel. Now let's take a look at 5600 Kelvin. With the exception of 10% brightness, the CCT is very consistent. The TM30 color render results do change a little bit at 10%, and the white point accuracy or delta UV is consistent at 100%, 50% and 25%. Then it skews towards magenta by about the equivalent of a 1/8 correction gel. Now let's take a look at the average CCT accuracies. Between 2000 and 3000 Kelvin, it is typically out by only 15 Kelvin. Between 3100 Kelvin to 4000 Kelvin, that drops to an average of only 10 Kelvin. Between 4100 Kelvin to 5000 Kelvin, it is typically out by minus 12 Kelvin. And from 5100 Kelvin to 6000 Kelvin, it is typically out by minus 34 Kelvin. Now let's have a look at the color render measured in TM30RF. Between 2000 Kelvin and 2500 Kelvin, there is quite a bit of shift. At 2000 Kelvin, the light has its lowest score of 60, and that jumps up to a very respectable 95 by 2500 Kelvin. From 2600 Kelvin to 3800 Kelvin, it scores a 96. From 3900 Kelvin to 5400 Kelvin, it scores a 95. And from 5500 Kelvin to 6000 Kelvin, where I stopped taking individual measurements, it scores a 94. Now let's have a look at the average white points measured in delta UV. Between 2000 Kelvin to 3000 Kelvin, it has an average delta UV of plus 0.0014. From 3100 Kelvin to 4000 Kelvin, that jumps up to an average of plus 0.0021. Between 4000 Kelvin and 5000 Kelvin, it's above the Planckian curve with an average delta UV of plus 0.0026. And between 5000 Kelvin to 6000 Kelvin, it has an average delta UV of plus 0.0025. Let's take a closer look at some of the CCTs now, starting off with the lowest Kelvin that we can dial in. When I dialed in 2000 Kelvin, I got 1978. The TM30 color render results were 60% average color accuracy with an average 97% color saturation. But take a look at the graphic because that average saturation is quite misleading. With the CRI scores, only 2 are above 90. The spectrum distribution is very anorexic, and the white point is reasonably good with a delta UV of plus 0.0006. Now the color render at 2000 Kelvin isn't that amazing, so I've also taken readings at 2400 Kelvin because from this CCT onwards, the color render is quite good. When I dialed in 2400 Kelvin, I got 2418. The TM30 color render results were 95% average color accuracy with an average 101% color saturation. With the CRI scores, only R11 is below 90. This is the spectrum distribution, and the white point came in with a delta UV of plus 0.0015, which would make the light at this point slightly green to somewhere around the equivalent of 1/2 of a 1/8 correction gel. When I dialed in 3200 Kelvin, I got 3212, with an SSI score of 86. The TM30 color render results were 96% average color accuracy with an average 102% color saturation. With the CRI scores, R12 is only just below 90. This is the spectrum distribution. And the white point came in with a delta UV of plus 0.0020, which would make the light at this point green to a little bit under the equivalent of a 1/8 correction gel. When I dialed in 4400 Kelvin, I got 4385. The TM30 color render results were 95% average color accuracy with an average 103% color saturation. With the CRI scores, only R12 is below 90. This is the spectrum distribution. And the white point came in with a delta UV of plus 0.0025, which compared to the Planckian curve would give the light a green hue to roughly the equivalent of a 1/8 correction gel. When I dialed in 5600 Kelvin, I got 5561 with an SSI score of 74. The TM30 color render results were 94% average color accuracy with an average 102% color saturation. With the CRI scores, R9 and R12 were below 90. This is the spectrum distribution. And the white point came in with a delta UV of plus 0.0025. So if your camera system's working to the Planckian curve, this would appear to be green to roughly the equivalent of a 1/8 correction gel. However, if your camera is working to the daylight curve, then this is very close. I've taken some additional readings here at 7000, 8000 and 9000 Kelvin. At the highest CCT of 10,000 Kelvin, I got 9,880. The TM30 color render results were 90% average color accuracy with an average 98% color saturation. With the CRI scores, R9 and R12 are below 90. This is the spectrum distribution. And the white point came in with a delta UV of plus 0.0022. Now, one thing I haven't mentioned yet is that these lights over DMX have an advanced HSI mode. So that means you can dial in any CCT you wish with any green magenta value and then crossfade in a color hue over the top of that. Speaking of colors, let's see how accurately these lights dial in their color vectors. Red or 0 degrees came in at 1 degree, green or 120 degrees was smack on, blue or 240 degrees was also smack on, yellow or 60 degrees came in at 31 degrees. But if you're looking at the tube, it actually does look like it's yellow. Cyan, which should be 180 degrees, was very close at 176 degrees, and magenta, which should be 300 degrees, came in at 284. So my closing thoughts, if you're looking for a tube that has weather protection and built-in CRMX, these would have to be on your list of products to consider. Now, congratulations to Godox, because if I was told a year ago that I'd be saying that about a Godox tube, I wouldn't have believed it. You've come a long way in a short amount of time. I'm Andrew Locke. See you on the next episode of Gaffer in Gear.